Algebra 1, Lesson 8 is all about area. Part A, we're just mentioning that the concept of area, area is the number of square units contained in a figure. Number of square units contained in a figure. So in something like a rectangle, that's pretty easy to see. We can come up with a number of squares here. This particular rectangle, whatever this unit happens to be, is 8 square units, because 8 squares cover that rectangle. And we're going to put formulas here for some of these areas, even though they are on your reference sheet, and hopefully you know many of these already. The area of a rectangle is length times width, and I make my L's cursive so they don't look like ones. And if you want the words, length times width. Okay, and then since a square has 4 congruent sides, the length is the same as the width, so we often just say that one is the length of a side squared. It's still length times width because it is a rectangle. Alright, so then we have this composite figure we are finding the area of, and it tells us all angles are right angles, so we can be splitting this into a couple of rectangles. You can choose to split it this way, or you can split it with a little horizontal line through there. Either way, you will get the same answer. I think the line I made was darker vertically, so we'll just go with this. Okay, so for this one, we would have this rectangle is 5 units long and 2 wide, so this one's 10. And then this rectangle is 2 by 4. Make sure you're looking at the right numbers. See which way you split the rectangle or the figure. That one's 8. If I had split it the other way, I'll just do a sketch down here real quickly. Okay, if I had gone this way instead, then what I'm looking at here, let me put all these numbers back. This rectangle is a 2 by 3, and this one is a 2 by 6. See, I'm still getting 18, no matter which way I split it. So 10 plus 8, or 6 plus 12, it's 18 centimeters squared. The units are square because when we were doing our area, it was 2 centimeters times 5 centimeters. Centimeters times centimeters is centimeters squared. So it's that. In the next one, we're finding the area of the shaded part. So we're doing the larger rectangle minus that smaller one that's inside. Okay, so we have the larger one minus the smaller one, and we have 80 minus 12, and that looks like 68. Dimensions are meters, so 68 meters squared. I did want to mention back up here on example 1, for your work on your problem set, you should show, like I was doing here, like what am I multiplying, what am I adding, or redraw the figure and show what you did. Of course, you're not writing in the book. Whoops, wrong side. We are ready for part C now. Okay, and this part is just about triangles. And this one should take care of questions I seem to get a lot. The perpendicular distance from either the base or an extension of the base to the opposite vertex, that is the height, but it's also the altitude. Altitude. Often in your problems it'll mention altitude, and someone's often asking what that is. It's the height. Synonyms. Okay, so in this one, This is the base. This is supposed to be a right triangle. This is the height. In this one, it's just some random acute triangle. That bottom side would be the base. And then the perpendicular distance from the opposite vertex to that base is the height. Over here we have our base. Here's an extension of our base, and then the perpendicular distance to that extension is the height. Area of a triangle, 1/2 base times height, or base times height divided by 2. Okay, example 3, find the areas of these triangles. Dimensions are in inches. Okay, so 1/2 the base times the height. 1/2 times the base times the height. 1/2 of 12 is 6 inches squared. Same base, same height, same area. Same thing. Okay. Example 4. Find the area of this right triangle. Dimensions are in feet. Okay, so at first glance, okay, here's my base. I need to find out what this height is. It can be done, but not exactly with the information we had. Well, yeah, actually it could be done, not with the information that you have so far. So what you need to think about is, how can I look at this thing? It's a right triangle. You could turn this around, so either one of these could be the base, and then the other one, the 6 or the 8, and the other one could be the height. Okay, because the height is the perpendicular distance from a vertex to the opposite side. That opposite side being the base. So the area for this one is 1/2 times 6 times 8. 1/2 of 48 is 24. What was it? Feet. So 24 feet squared. All right, in this next one, we could split this into a rectangle, and it does tell us corners that look square are. So we could split this into a rectangle and a triangle, or we could just do 2 triangles. And I'm going to do 2 triangles. Okay, so what we have here is, again, if it looks like it's a right angle, it is. So this one is a right triangle. We can do it similarly to this one. 1/2 times 4 times 6, 1/2 the base times the height. We could look at 4 as being the base, then 6 is the height. For this one, 10 will be my base. So I'm adding to that other triangle, 1/2 the base, and then the height is the perpendicular distance. Okay, from there to there is the same as that, so 4. And then we go ahead and calculate this one. So 1/2 of 24 is 12, and 1/2 of 10 is 5. 5 times 4 is 20. So we're looking at 32 yards squared. Now, this is a trapezoid. You have a formula on your reference sheet. You can use that. You could also have done a rectangle and a triangle. Like you can see here, I'm showing what the height was. I drew that line anyway. You could do this rectangle and that triangle. Many options to choose from. All right, moving on to circles. Area of a circle. This also is on your formula paper, but it is pi r squared. You need to know the radius, and then you can get the area of the circle. Radius, of course, being from the center to any point on the circle. Okay, so the radius, example 6, the radius of a circle is 3 centimeters. Find the area. Alright, so area equals pi r squared. This r is a 3, so pi times 3 squared. The area is 9 pi centimeters squared. You can leave it like that. Okay, for our purposes, you can leave it like that. If you needed to know how many square centimeters that actually is, of course you would take that times 3.14, or if using a calculator, use the pi button. It goes out many more decimal places. For this one, that'd be about 28.26 square centimeters. The area in example 7 of a circle is 25 square meters. We're supposed to find the radius. Okay, so I'm going to write the formula, pi r squared. In place of the area, I'm putting 25. Okay, so that means I need to divide both sides by pi, because I need to isolate that r to find the radius. And these are the ones that you can do this by hand if you use 3.14 and do the long division, but you're allowed to use a calculator. So now we have, just cleaning that up, r squared, because those cancel, is whatever 25 divided by pi equals, which you can do in your calculator. It's about 7.96, okay, approximately equal to 7.96. 24 divided by 3, rounding both of them would be 8, so you know that's close. And then the square root of that is approximately, because I'm rounding both times, 2.82 meters. Now, in order to round less, what you do is on your calculator, you can do that whole thing at once. The square root of 25 divided by pi. But that is what you get. Oh, yeah, it's just radius. My units are not squared, it's just the length, and so I've circled my answer now. Okay, so we're back to finding area in example 8. Lines that look parallel are, I'm going to label that. Those two are parallel. Okay, and the dimensions are in inches. Okay, so we have a half circle up against a trapezoid, or we could split this into two triangles, or a rectangle and a triangle. I did two triangles last time. I guess I'll do a rectangle and a triangle this time. And again, you could just do the trapezoid formula with a half circle as well. Okay. So, if this segment is 5 and this is 7, okay, from here to here is 5, this has to be 2. And my height, here's a radius of that half circle, so my height is 4. So we have the triangle is half its base times its height, and then we have a rectangle that is going to be a 4 by 5. And then the half circle is half of pi r squared. And instead of r, I'm putting a 2. Okay, pi r squared would be the entire circle. Half of that would be a half circle. So here we have 4 plus 20 plus, okay, so this is 4. Half of 4 is 2, so plus 2 pi. So 24 plus 2 pi inches squared. You can get a decimal answer if you want to. You would just take 2 times pi and then add the 24 to that. It would be approximately 30.28. Inches squared. If you're leaving pi in your answer, remember, this 2 is being multiplied by pi. This 24 is not being multiplied by pi. These two are not like terms. This is not equal to 26 pi. 26 pi would be much larger than 30. Okay. Last section in these notes is about parallelograms and trapezoids. And you can divide these shapes into triangles. 2 triangles. Alright, so the area of a parallelogram is the base times the height. But if you forget that, you just do this and do 2 triangles. Okay? These 5s are extra information. You do not need them. They are not the height. Your base is 8. Your height is 4 for both of those triangles. Half of 4 times 8 plus half of 4 times 8. Or 8 times 4. Okay, and you see the whole thing is just base times height. So if you remember that, for a parallelogram, it's just base times height. It does not work that way for trapezoids, but you have a formula. Anyway, so half of 32 is 16, plus half of 32 is 16. But when I add them, I'm getting 30. Oops, forgot my units. 32 centimeters squared. Okay, now, the trapezoid. You have a formula, but you don't need to memorize that formula because, again, you know you can split this into 2 triangles. And so if you know the area for how to get the area of a triangle, you can do trapezoids, parallelograms, and triangles. Okay, so 2 triangles. We have 1/2 this base times height, so 15 times 4. Again, they gave us extra information. And the other triangle, if you think about flipping this around, this would be the base. So the base of that one is 9, and the height is still 4. Okay, half of 4 is 2. 2 times 15 is 30. Half of 4 is still 2. 2 times 9 is 18. So this looks like 48 meters squared. And that's it. Have fun with all these area problems.